Hello, my name is Jordan Pope. I'm the mechanical engineer at Surefire Ag, and this is a little bit of what I did this summer. So firstly, I'll go over my expectations and goals coming into the summer. I was expecting to have minimal actual engineering experience, basically just observation of what engineers do on their day-to-day work. And then I'm certified in SolidWorks, so I was expecting to have to use that programming. My goals were to observe engineers and their careers as sort of a career path for myself to make sure that it's what I want to continue doing. My experience, or to get some more experience working with engineers, and then to discover the real-life application that Surefire Ag has with farmers. Coming out of this internship, my experiences included daily real-life work with engineers, on-site practice with customers and our equipment that we sell, and then our personal products and then I got to affect personal products that we directly sell to customers that are the Surefire products. My accomplishments this year, or this summer, excuse me, I got to completely remodel the Surefire Spartan Pump injection, Surefire Spartan injection pump system. I got to model a mass and flow meter verification stand, and then multiple clamps and brackets for both of those systems. My first project of this summer was the mass and flow meter verification stand. The problem with mass and flow meters is oftentimes when customers misuse them, they'll break, and then they send them back to Surefire to test so that we can figure out what the problem is and fix it for the customers. We needed a quick and easy way that we can hook up these systems and verify them with another system. So my job was to create, as you can see in the bottom left, that holds both of these systems and then test them a lot more quickly than you would usually do. My assignment was to model this assembly so that it holds two separate flow meters that we can run product through and test both of them. Okay. My first sub-project for the flow meter was to create a flow meter clamp. The idea of this clamp is to create a clamp that we can quickly fasten a flow meter to its couplers without having to bolt it to the sheet metal. Obviously, if we're looking for efficiency in testing these flow meters, we need something that can be a lot quicker than screwing 8 bolts down and then unscrewing them after we get done. As you can see in the top row, those are my 3 different models that I came up with. The one closest to me is the final product, and it works pretty well, holds water. My design process, the necessary components I needed to accommodate for in this project, I needed to accommodate for 2 mass meters, the verification and the failed meter, an electrical box, a control screen, switch, an electromagnetic flow meter, plumbing to connect everything together, and then the mounting holes to mount it to the bracket. As you can see in the top right, that is the final project today. We got it assembled. It works pretty well. My second project of the summer was the Spartan Pump redesign. This was my major project of the summer. The goal or the problem with our prior Spartan Pump designs is all of them were belt driven, and they all relied on float switches and signal conditioners. The problem with belts is oftentimes they'll break down. It's one of our biggest mechanical breakdowns of this specific pump. And then float switches rely on a calculation rather than a measurement of the product being flown through the pump. So my assignment was to create a directly driven pump that uses a flow meter instead of the float switch. And as you can, these 2 in the bottom are our prior designs. So you can see in the back there, it's covered by metal sheet metal, but there's a belt back there that I replaced. The top left is my first design of the one pump system. And here's my design process. So the necessary components I needed to accommodate for in this assignment were the pumps, 1 or 2 depending on the model, the flow meters, the 006 or 008 depending on the model. The 006 goes for the 1 pump, the 008 goes to the 2 pump. It's just a different flow meter for the amount of product we can output through this meter. EPD or electric pump drive, the plumbing, and then mounting holes again. You can see in the top right that is all of the sheet metal for the Spartan pumps. I just thought that was cool. We toured the sheet metal factory and I got to see that. The bottom two pictures are my SolidWorks files of the final products for the 1 pump and the 2 pump. And then the top left is a picture of the fully assembled 2 pump design. Lastly, the field experience I got with this internship was very valuable in my career. Firstly, I got to evaluate and measure a John Deere DB90 planter for Surefire systems. The goal of this, you can see the picture of the planter in the bottom left. The goal of this sort of field trip was to go measure this planter so we could model it up in SolidWorks so that we could better fit all of our pumps and tanks towards this planter in the future. Secondly, I got to tour our sheet metal fabrication factory. So as I said, with the Spartan pump, everything that we model in SolidWorks we send out to this factory and they print it off, they laser cut it, as you can see in the bottom right, and then they fold it together and paint it, and then they send it out to us. And then lastly, I got some engineering and sales experience at the retreat that we had in Kansas City, which is very valuable for me to see more of the company-wide projects rather than just my very specific engineering problems, which I thought was really cool. Thank you for having me. Thank you, Nex-Gen, for giving me this opportunity, and Surefire for hiring me. I really appreciate it.